Welcome to Effortless Math Channel. Today, we're going to learn how to evaluate the sum and difference of two rational expressions, and we'll learn how to provide the answer in the simplest of forms. What are rational expressions? Rational expressions are fractions where both the numerator and the denominator are polynomials. Another way to think of these expressions is as a ratio of two polynomials. So here are some examples. 2 over x, 3 divided by x plus 4, and the more complicated 5x minus 1 divided by x squared plus 5x minus 2. So there are some rules to adding and subtracting these expressions. The rules are the same as when you're adding and subtracting fractions. Therefore, you want to make sure that when you're adding and subtracting, you're only doing so with the numerators. You should not be adding and subtracting the denominators. However, the key is that when you add and subtract, you cannot do so unless the denominators of the two expressions are the exact same. No exceptions. So let's take a look at this first example here. 2 over x plus 5x over x. Can we add these two expressions the way it is that they are? Yes, absolutely. The denominator is the same. We have an x in one term and we have an x in the other term. Therefore, what we can do is we can combine the numerators, only add the numerators, 2 plus 5x, and put that over the same denominator of x. That would be our final answer. Can we subtract these two expressions? No, we can't, because the denominators don't match. So what would we do in this situation in order to combine the two? Well, we'd have to find the least common denominator. When the denominators do not match, we do this process in order to get the same denominator. So let's look at this example here. The least common denominator, or the LCD, in this case will be as simple as finding the product of the two denominators. The least common denominator is going to be something that we can multiply both the denominators to in order to combine the two expressions at the end of the day. Now let's look at this example over here. This one's a little bit more complicated. So in this case, the first thing that you should do is factor. Factor the denominators, both of them, if you can in both cases, in order to help you best determine what the LCD is. X squared minus 4 breaks down into x plus 2 and x minus 2, whereas the other denominator of the other term, x times x plus 2, is already broken down, so we don't have to worry about that. Now the next step is, what do these two have in common, if they have anything in common at all? Well, they both have x plus 2 in common. Therefore, that will end up being part of the LCD. But we're not finished. The LCD will also contain any other terms that the two denominators have that maybe they don't have in common. Therefore, these two terms are x and x minus 2. And when we combine everything all together, our LCD will be x times x plus 2 times x minus 2. Now, let's go ahead and evaluate these two examples that we went through, starting with the first one. 2 divided by x plus 5 divided by x plus 1. We already figured out that the LCD is x times x plus 1. So how do we apply this LCD in order to get the same denominator? Like this. We had to multiply each of the rational expressions by the respective missing factor. 2 divided by x is missing x plus 1. Therefore, what we'll do is we'll multiply the denominator by x plus 1. However, we can't only multiply the denominator. The entire expression has to be changed in order to be balanced. So what we do to the bottom, or the denominator, we have to do to the top, or the numerator. And we do the same thing with 5 divided by x plus 1. This term is missing an x, so we'll multiply by x both on the top and on the bottom. When we do so, we end up with this line here. This is the more simplified version. And then the next step is to add our numerators, combine everything all together, and simplify. So we'll rewrite the previous line. We're doing addition here. And everything can be combined over one denominator. That was the point of the LCD, making sure that we can put everything on top of one denominator, one expression. So with our 2 times x plus 1, we can distribute out the 2, and we'll end up with 2x plus 2, carry down the 5x to have plus 5x on top. The denominator stays the same, we leave that alone. And now we can combine like terms. 2x and 5x both have an x, so we can combine those, add them, and that will equal 7x, and we can carry down the plus 2. So our final answer in this case, our most simplified answer, will be 7x plus 2 divided by x times x plus 1. Now, let's go to our second example, which is a little bit more complicated. X minus 2 divided by x squared minus 4 minus 5 divided by x times x plus 2. Our LCD, we've already determined by factoring out the denominators, is x times x plus 2 times x minus 2. So let's go ahead and apply those. However, first, we should rewrite the expressions like we did before. So the first expression now will be broken down into x minus 2 on the top, and in the bottom we'll have x plus 2 times x minus 2, the two factors. And the second term will stay the same. That's already broken down. Then we can go ahead and multiply each of the terms by the missing factor of LCD that they don't have. The first term is missing an x, so I'll multiply top and bottom by x. And the second expression is missing an x minus 2. So we'll multiply the top and the bottom by x minus 2. At this point now, we have the same denominator for both terms, so we can combine everything into one expression like this, and now we can distribute out everything. However, take a second to pause and take a close look at this expression that we have here. One of the things it is that we try to do is simplify. And if you look closely at the expression that we have here, each of the terms that I'm going to circle here has something in common. Each of these has the x minus 2 in common. Therefore, in this particular case, rather than distribute out the numerator, we can forego that step, and instead we can cross out like terms, just like this. When we cross all of those out, and the only reason that we can do so is because each of the terms in the numerator and the denominator has this x minus 2, we end up with x minus 5 divided by x times x plus 2. This is our answer, our simplest answer. To recap, today we learned how to add and to subtract rational expressions. We learned how to figure out what the least common denominator, or the LCD, is, both in a simple and a more complex case. And we learned how to best simplify our answers. Thanks again for watching Effortless Math Channel.